Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the solutions of S2 variant 72 of November 2018. And for this, I'm using the work of an outstanding and one of my best students, Miss Sayyida Aiza Gardezi of class 2021, the Lyceum. Well, all instructions are very important, especially this one. Give non-exact numerical answers correct to 3 significant figures and so on. An important advice for me and for everyone, we should be fair to others. Well, this is the work by Miss Sayyida Aiza Gardezi of class 2021. An important advice for me and for everyone, we should be soft to others. Question number 1. The random variable x has the Poisson distribution with lambda 2.3. Find this probability. This 2 is inclusive and this 5 is exclusive. So the possible numbers will be 2, 3 and 4. And you all know how to use Poisson distribution formula to get this probability. And make sure you give your answer up to 3 significant figures. Question number 2. The standard deviation of the volume of drink in cans of cola is 4.8. A random sample of 180 cans, this is the sample size, and the mean volume is 330.1 centiliters. So we have standard deviation, we have sample size, we have mu. Calculate a 95% confidence interval for the mean volume of drink in all cans of cola. Give endpoints up to 1 decimal place. This is very important. Since distribution is unknown, so according to central limit theorem, x bar is approximately normal. Therefore, this is the formula for confidence interval, and we have to construct this interval at 95%. So 95% means this total area is 97.5%. So this is the value of z. So x bar is here, z is here, sigma and ns is, they both are here. Make sure you give your answer up to 1 decimal place. Explain whether it was necessary to use CLT in your answer to part 1. Yes, because it has not been stated the population is normally distributed. Because the population is not normal, not stated. Question number 3. Sugar and flour for making cakes are measured in cups. The mass in grams of 1 cup of sugar has the distribution. It is here. And the mass in grams of 1 cup of flour has the distribution. Each cake contains 2 cups of sugar and 5 cups of flour. So you have to take the total mass. Find the probability that the total means sum mass of sugar and flour in one cake exceeds 1310. These numbers are not multiples of S and F. You can denote this as F. So we need total. First we need mean of this. So mean of S is 250 and mean of F is 160. In variance, don't square these numbers because these numbers are not multiples of S and F. So this is sigma square and this is mu. More than 1310. So this is the way to get the probability. We need this area. This one. So this should be 1 minus phi 1.240. Or if you are using the latest version of the calculator, then you first get this area and then subtract this from 0.5 to get this area. You have option, you can do anything. Next question. Question number 4. The time x hours taken by a large number of runners to complete a race is modeled by the probability distribution. This is the largest value of the model. Show that k is this, I'm sorry. By using this formula, all x, fx, dx 1 equals to 1, we can easily prove this. So it's here, all x means 0 and a, lower and upper limits. The function is here, and this total area is 1. Because total probability is always 1. You have to bring this in numerator, and then you have to integrate this and apply the limits. Do the calculations carefully. Here is the answer. Next part. State what the constant A represent in this context. This constant A. This means maximum hours taken by a runner to complete a race. The largest time, maximum hours taken by a runner to complete a race. 3/4. 3/4 means 3/4. Of the runners take half an hour or less to complete the race. Half an hour or less, that means 0.5. And this probability is 3/4. Find the value of A. So this is so simple. Upper limit is 0.5 because we need this probability. T less than equal to 0.5. So this is the upper limit. The lower limit is 0. So we have, and we have this probability. This is 0.75. So by integrating this and equating the answer to 0.75, we can easily get K, the value of A. K is this, so A is 0.8. You must be good at integration. This is -2. Question number 5. The numbers of basketball courts in a random sample of 70 schools, this total is 70, in SM are summarized in the table. Calculate unbiased estimate. This is so simple. You can easily do this with the help of this formula. Sigma fx over sigma f. So here is the mean and sigma cap square. This is also very simple. You can easily do this. You need to divide this by 70 because this is sigma fx square over sigma f minus mean ka square, square of mean. So this answer is here, 0.858. Must give your answer up to 3 significant figures. Second part of this question, the mean number of basketball courts per school in North M is 1.9. So mu is 1.9. Test at 5% significance level whether the mean number of basketball courts per school in SM is less than. So we have a lesser sign here. This is in NM and this is in SM. 5% means this thing. Negative 1.645. So this is Z test. We just need to observe whether this Z test lies in critical region or not. Since this number does not lie in critical region, this lies here in accepted region, therefore we have to accept H0. So accept H0, that is the mean of basketball courts per school in SM is not less than in NM. You have to accept this thing. The claim is rejected. This is rejected. State with a reason which of the errors, type 1 or type 2, might have been made in these tests in the part 2. Since we accepted H naught, therefore type 2 error might have been made. Type 2 as H naught was accepted. This depends on the conclusion. Since we accepted H naught, therefore type 2 error. What if we rejected H naught? Let's suppose. Then type 1 error. So always give this answer in the context of this conclusion. Question number 6. In the past, A found that his train was late on 15% of his daily journeys to work. This is binomial distribution. This is the P of binomial, H naught. Following a timetable change, A found that out of 60, this is the sample size, his train was late on 6 days. This is the test value. Test at the 10% significance level whether A's train is late less often than it was before the timetable change. Less often means less than sign. H1 has a lesser sign. The timetable has changed. So we have to perform the lower tail test. Since n is very large, this is greater than 30, so we have to use normal approximation, and for that we have to use continuity correction. So the test value is always inclusive, so 6 is here. Since we are going on this side on the number line, so we have to take the upper bound. So 6.5 minus NP is 9 and NPQ under root, and this is the Z test, and we have to perform the test at 10%. So at 10%, the value of Z is minus 1.281. Since this number does not lie in critical region, it lies here, therefore we have to accept H naught. That means train is still arriving late. Next part. A used his random sample to find an alpha % confidence interval for the proportion of days on which his train is late. The upper limit of his interval was 0.150, correct to 3 significant figures. Calculate the value of alpha correct to the nearest integer. Number 1, you have to find PS. So PS is 0.1, 6 out of 60, and QS is 1 minus PS. So this is the formula of confidence interval, and confidence interval, the formula for confidence interval is this. If you will ignore this negative sign, this is the upper limit of the confidence interval. So by substituting the values into this formula and using this upper limit 0.150, we can easily get the value of Z. Once we get the value of Z, the value of alpha is very simple, because this is alpha. So this value is 1.291, whereas this value is minus 1.291. If you are using the latest version of the calculator, just put these two numbers in your calculator as lower and upper limit and get this answer, 80%. If you are using table, then get this answer. This is 10%, so this is also 10%, so alpha must be 80%. This total area is 90%, and alpha is 80%. Next question, number 7. The independent random variables x and y have the distributions 2.1, 3.5. X follows Poisson, y follows Poisson. We need sum, so x plus y. So the lambda will be 5.6. We need exactly 3. Here is the formula of Poisson, and this is the answer up to 3 significant. This is the conditional probability question. Given that x plus y is 3, so this answer should be in denominator. This should be here. And instead of using this, use the accurate answer. Find x2. So x plus 3 is 3 and x2. So x2 means, this means y must be 1. Because their total must be 3. So this is the formula of conditional probability. Here is the formula. X should be 2 and y should be 1 because the total must be 3. So x2, probability of x2 is here. Use the lambda of x, which is 2.1. For 1 is here, and this is the answer of part 1, and this is the answer up to 3 significant figures. Part 3. A random sample of 100 values of x is taken. Find the probability that the sample mean is more than 2.2. This is the sample size. We need this probability. Sample mean is more than 2.2. So x is normally distributed, and n, this is mu 2.1, and this is the variance. It's here. Poisson, so x is Poisson. So x bar is approximately, because of this sample size, x bar is approximately normal, 2.1 over 100. Now use this and get this z. This is z. In terms of probability, you should write this as. This was fine, but this is better. Z greater than this number, and you all know how to get this. This is 0.6901, and we need this area. This is the requirement. Since this student is using table, so she is finding this area first. And 1 minus 0.6901 is this answer. An important advice for me and for everyone: we should be generous. Good luck. And I'm extremely thankful to Ms. Saida Aida Gardezi, who helped me to make this lecture. Indeed, she is an outstanding student. May Allah Pak bless her always. Ameen. Allah Hafiz.